Hi everyone, this is the Decentralized Voices podcast. My name is Daria and I'm excited to have Dr. Muriel Médard, co-founder and CEO of Optimum. In this episode, we'll discuss building a product with high-performance memory for the world computer, the intersection of deep tech and community growth, and career development for women in tech and science. Muriel is a role model for many people in the Web3 space, and I hope you'll stay with us till the end of this episode. Muriel, I'm happy to have you today. Please give a short overview of your professional background.
Yeah, thank you. Thank you so much for having me, Daria. Ever since we got to meet and chat and chat, been very much looking forward to our conversation. So, as you mentioned, I am co-founder, CEO of Optimum, and Optimum is actually a spin out from the work that I've been doing at MIT. At MIT, from which I'm on leave to pursue full-time Optimum, I hold the NEC chair in software science and engineering. It's a School of Engineering wide chair, but my tenure as a full professor in electrical engineering and computer science, at least since basically the start of the 2000s, of the network coding and reliable communications group. I'm in the research lab for electronics. My path has been basically as a faculty member for almost the entire time, except for a couple years in the research lab. And I have been working for over 2 decades in decentralized coding, where coding is algebraic manipulation of data for its more optimized representation, whether it be optimized for robustness or whether it be optimized for space efficiency, etc.
Thanks for sharing. And as far as I know, you earned 3 bachelor's degrees. Yes, is it right?
And true, yes. Actually, MIT does not allow you to do that anymore because I think so many people were trying to kind of killing themselves in the process. But at the time you could. But I like to joke that it's not because of that, but because they go, no, the last one we know about was Muriel, and she's such a pain. We don't want another one like that. But I did 3 degrees, and actually my career path was a little funny. So I finished high school in France, and in France you have to specialize very early. And I finished high school at 17, and I really didn't know what I wanted to do. And the idea to go and specialize, and just take more exams and so on, and just go to whatever school you get the highest score for, was a little daunting. I went to MIT in great part because I did not have to pick my major the first year. You could explore. And I went thinking I'll just be a math major, because I was like, okay, I can do math. I know that. And so I went to be a math major. And then in part of my exploration took a course in electrical engineering. Did. And by the way, just you were talking about the 3 degrees. So actually my 3 degrees, one of them is electrical engineering and computer science, one of them is math, and one of them is humanities, but is actually I did Russian literature, Slavistika, and I didn't have any Slavic background at all, but I loved the literature. So I did those 3 degrees, mostly 19th century literature. And so I love the math and I love the literature, the creative side of literature, but I liked, the rigor of math. And then engineering was like a total revelation because it had the really concrete and rigorous side of math.
Yeah.
And then it had the creative side of literature. My mind was blown. It's like, wow, you can do both. So then I couldn't make up my mind, so I did those 3 degrees. But yeah, that's an unusual mix. Yeah.
Yeah, and you're a well-rounded person having this more humanitarian education and tech-focused.
So anyway, so that was my background. So it was definitely one of just doing what interested me at the time. And then I continued for my graduate degrees at MIT in electrical engineering and computer science.
Yeah, so and I know that you're author of more than 1,000 of papers and a lot of patents, 80 patents.
The stage, yeah.
It's incredible. And what did you do to achieve these numbers and what's the result you have now?
Yeah, so that's a really good question. It was always because it was stuff that was interesting me, or I had a student who wanted to do something that was interesting. We just went with it. Certainly, as a profession, it's been a really, really amazing ability for me to pursue these sorts of things in with super, super fun, smart, motivated people. And so it wasn't that planned. I know sometimes people ask me about career planning advice, and I'm thinking, really asking me? So
Actually, I also wanted to ask you, yes.
no, like I'll give you one vignette that sort of tells you how non-career planned I was. So when I finished my PhD, I was uh I started my family while in university, so already had one of my first child, and she was in a little preschool that she just loved. So I was like, well, the main thing is for my job to be close to the preschool. Now nobody chooses a job that way, right? I mean, it's ridiculous.
Yeah, yeah.
So I interviewed two places that were close to the preschool, and I got multiple offers in different groups from the two places. And one of them was Lincoln Lab, and I chose the only offer that had nothing to do with my doctorate, figuring, well, I'll learn something new. Now, if somebody was telling you they did that, you would say that's a really stupid idea, right? So, but that's what I did. And it was interesting, right? I said, well, I don't know how long I'm going to be in this job. I just, I had to go to work because, I had to like feed the family. And so I thought, okay, my then husband was going back to graduate school. Somebody had to literally feed the family. So, uh, and so I thought, well, I'm going to do something interesting while I'm here. I'll learn something. And it was actually in optical network security. And it was fascinating. I had done my master's in optical networking. I had done my doctorate in information theory. Actually, Web3 has a lot of founders who are also information theorists. Um, and and that's basically how it came about. So it's not very planned. I think if I had to give advice generally is try to do something that you think is really worthwhile and interesting. You don't know where it's going to go, but at least
Yeah.
if it was worthwhile and interesting while you're doing it, it's a worthwhile, time. So you spent your time in a productive way and you will learn something. And while you're doing it, do it well. So that would be my advice. And it doesn't mean that it will always work out, but at least it will mean that you won't look back at it with regret.
Yeah.
You'll say, oh,
Yeah, for
actually,
sure.
I did that because I thought it would be interesting and I would learn something and I could contribute. And I did. So that at least and it works out, I think, often. Yeah.
Yeah, thank you very much. And can you please share what is Optimum and how does it provide performance memory for the world computer? Because it sounds very ambitious and very huge.
Yes, yes, absolutely. I'm going to go back to the 1940s. So we're right after World War II. And John von Neumann had landed in the U.S. and he created what is often called the von Neumann or the Princeton architecture for a computer. Now, remember again, World War II. There's there's a huge boom in computation and a computer. We know of the Enigma machine.
Yeah, yeah.
And actually, I'll do a plug for one of my favorite history books. Is actually by Hugh Sebag Montefiore, and it's about the Enigma machine. And I highly recommend it. And it has a lot of original research in it. It's fascinating, and even for technical, even though he's not technical, for a technical person like myself, it's very intelligently written. So anyway, Turing, etc. People are like,
Yeah.
what is this thing? What is a computer, right? And so he defined what a computer is. And he said, okay, it has an input, right? You have to tell it what you want. It has an output. It has to tell you what it did. And in the middle, you have the compute part, which has the controls, what we would think of as the operating system, what he called the arithmetic logic unit, what we would probably think of as kind of like the CPU.
Uh-huh.
And then it has a connection, which we would call the bus, and the memory. And that's a computer. So we always think of the computer as the computing part. But
Uh-huh.
actually, from the get-go, it was fully integrated with the bus and the memory. That's basically what's core to the computation. Is not just the computation. You can't compute on nothing.
Yeah, for sure.
You can actually take data and not compute on it. It's the identity function, my favorite function ever. I always know how to compute it, but you can have memory, no computation. You can't have computation, no memory. It just like literally doesn't work. It's the core element. So Now, if you're going to look at decentralization, and as I mentioned, I started working on decentralized coding in my group very early on, and the number of times I've had colleagues, friends asking me, sometimes with a little bit of well-meaning concern, why are you working on decentralized stuff? Like nobody does this, right? We're talking early 2000s, like nobody does this. The idea is if you're going to now do the data representation, which is the memory, and I remember I mentioned information theory is really about data representation, about making it succinct, making it reliable, representing the data, the information, as the information theory name indicates. Then what you're doing is are taking the data and now exploding it over a network. And that's what network coding does. And so there had been some early work on network coding, end of the 90s, the late great Rudy Alsvede, my sadly departed pal Ning Tsai, etc., Raymond Young and others. But it was all looking at it over a network with a centralized controller, and it's like, this is just not going to work, right? I mean, you could do it, but it's going to remain more of a mathematical curiosity. And I had started working with another late departed friend, Ralph Coder, and we started looking at the entire network as just being one big algebraic function. Coding, as I mentioned, is about algebraic manipulations. And I said, I am doing algebraic manipulation, but I'm doing it over an entire network. And that was our first work on algebraic network coding. And then once you had that mathematical framework, you went, wait a minute, what if you picked the elements of that function, the different nodes, in a completely decentralized way, randomly? What would happen? And the answer is it works. And it's not just it works, like you cannot make it work better. Like it is actually Optimum, hence the name of our company. So it's Optimum. And then, things like gossip, what algebraic gossip. Again, Optimum if you just do it in a completely decentralized way. So basically, that algebraic structure led the way to being able to do everything in a decentralized way. And then I was hooked. Right? Because you go, wait a minute, you can do all this in a centralized way. And by the way, I'd like to say a little bit about decentralization, because why were we really looking for decentralization? There are different ways in which people become interested in decentralization. You would know better than me, and I'm sure your listeners, the community who listens also all have the different reasons. Some of them have it for, philosophical reasons. They think that this is the only way to really have decentralization. Others come at it for different reasons. For me, the reason was just technological necessity. Something will not scale if it's not decentralized. That's it. So it doesn't matter whether you like it or not. I happen to like it, but like literally, who cares if I like it or not? Gravity is there whether I like it or not, right? Some days I like it, some days I don't like it. But I mean, the point is that you cannot have a system that is going to grow and where you need to get a lot of information, because eventually the size of the information to control the system is going to basically become too large. So the system sort of fall, just crumble under the own weight of its information requests for having state. So if you need to have a lot of state and control everything to optimize it, you're doomed, right? And it's not my fault. It's just the way it is, right? So the reason to me this was really exciting is like, okay, this means that it will scale.
Okay, thank you. Thanks for great explanation. And what kind of products or solutions can use Optimum?
Yeah, absolutely. So, as we said, we're doing the entire memory layer. And by the way, this means that we can run with different things, right? We're in the same way that, you buy a computer, you put in a bus, you put in a memory, those two have to be, well matched to each other. But you could decide to have a different operating system, right? So for us, you could have an EVM, you could have an SVM, you could have a whatever. It doesn't matter. So the first product that we have in testnet currently is the bus, right? Because the bus gives you access to the memories. We're working through it in a systematic and reasoned way. So that's our Optimum P2P, our MUM P2P, which is, a decentralized propagation algorithm. And basically think of your propagation layers and all of the different kinds of chains that we know and love, whether it's basically gossip sub in something like Ethereum, whether it be something like Turbine, I think now, switching over to Rotor in something like Solana, et cetera, et cetera. Different chains have different roads with it. So basically what we're able to do is to say, look, whatever resources you have available, or whatever nodes you have available, whatever link capacities you have at your disposal, we will propagate optimally. Right? That's it. I don't have to tweak anything. I don't have to find out who's doing what. This is the beauty. Like, I don't care. Like, you could come and tell me. And, these are very strong results. One of my former students, Bernard Hoppler, had actually showed some really strong results where basically, even if I had an attacker who's trying to slow me down and, has some, so like a Byzantine attacker who gets multiple. Yes. And even if I knew ahead of time exactly what the attacker is going to do, and I could find out everything that's going on in the network, I actually would not care. Like, I would not, like, the state is irrelevant, right? And so it sounds crazy, but the math is the math.
Yeah.
And then I get this all the time. Well, couldn't I do better? And it's like, no, you can't. You just, do more work.
Math. Yeah.
Probably can't do better. That's just the way it is. And so basically that kind of approach means that we're able to increase the throughput in the propagation and the dual of it for the same amount of traffic. We can massively decrease the latency. And we've shown that with some of our testnet results. 100 nodes all over the world. We have a bunch of wonderful testnet partners, Everstake, Kiln, Google Nodes, et cetera, et cetera. And basically what we're able to do is show massive differences. When the system is lightly loaded, we show about a 2x improvement. When the system starts to get heavily loaded, our improvement goes to 30x and above, right? In terms of latency. It's basically what the theory tells you. And you can see the theory. Going back to why I got into engineering, it's like you do the math, you build it.
You can see it, yeah.
You can see it. Again, it's mind blowing, right? It's really satisfying. So that's the approach.
I saw on your website the description of random linear network coding. What is this, and can you explain how it works?
Yeah, absolutely. So I mentioned before that, very early on, after Ralph and I did the algebraic coding, network coding work, we then started seeing, how do you pick a code? So remember, codes are equations. So how do you pick the equations? You pick the coefficients in the equations that correspond to the different variables. What we said is, every code is now in a network, not created just in one location. So traditional coding methods like Reed-Solomon codes, some people may be familiar with them because they're used in current DA solutions like Larry Celestia used two-dimensional tensor Reed-Solomon codes. People may be familiar with some fountain codes because Monad uses it in their propagation. So if you look at all of these codes, you have a single source that does all. And now in a decentralized way, we want to have all the different nodes in the network, each of them participate in the construction of the code. So a node takes in equations, mixes them. So these are linear equations, hence the linear, mixes them and outputs new equations. And the mixing of the equations is done using random coefficients, hence the R. So random, linear. And then it's a coding, you're making equations, and then it's done over a network. Hence a random linear network coding. You're doing linear equations randomly in a network, the equations are.
Yeah, thank you. Sounds reasonable. Yeah. Okay, so I see that Optimum stands out from other blockchain products, obviously, and not only technically, but I know that you have more than K members on your Discord. So can you explain how did you achieve these numbers and how everything works?
Yeah, so I think that so we're super grateful to have such a great community. I mean, we're extremely fortunate. I can't speak for them, but I think I can maybe say or try to articulate why I think this can involve such a huge community and in a way which maybe other projects are not inherently set up to do.
Uh-huh.
So remember this complete decentralization, right? So right now, I think if you look at Web3, you can participate in a couple of different ways. You can be, let's call it just a user, right? So you can buy, sell, and basically participate as a consumer. You can participate in the infrastructure, but then you generally are a node operator.
Uh-huh.
And being a node operator requires, pretty big investment. You have to buy the machine.
Yeah.
You have to stake, often if, every 32 ETH or something, like,
Yes. Yes.
yeah,
We know. All know this. Yeah.
we all know this. Yeah, it requires real money. And it's not just that. You also need to be in a part of the world where you're really sure that your connectivity is going to be good.
And electricity is pretty cheap.
And electricity is pretty cheap. My parents worked at the UN, so all over. I was often in places, I'd spent years in places where, you'd get electricity literally one day out of two. So, you sort of planned your life around that. You did the stuff that needed electricity one day and the next day, it's just candles and it was all fine. But, not if you're running a node. If now you look at Optimum P2P, and then actually this will naturally lead into what our next set of products is. So back to the part of the conversation we were having before. I opened my laptop and remember that granular network coding, you're just taking some equations, making new equations and sending them, right? Any equation I send is useful. But if I don't send it, that's okay. I just don't get a reward. So you basically have now the ability to run a node, we call these flex nodes, with basically just a computer, even a computer with intermittent connectivity. And, when it's on and you're doing work, you get rewarded. You don't get penalized or slashed for the work you didn't do. You just get rewarded for the work you did do.
Uh-huh.
Barrier to entry, both in terms of the cost of the hardware. By the way, I talked a little bit about our testnet. One of the things that we do in our testnet is we lower on purpose, we lower the capability of the nodes to get to just half a CPU and a few megabytes of memory. So we're talking really, really minimal computer memory in order to see if the nodes are still helpful, and they still are. So basically here you've opened your computer, you're doing your email, you're going to be here for a few hours and you get to collect rewards and you're collecting rewards because you're helping people, right? It's so if tomorrow you don't have power, it's okay. You're not penalized. So now think of the community that you can reach and who can be actively participating in a positive, useful way in the infrastructure. It's, relative to the community that is already there, it's massive. It's really
much more. Yeah.
I spent parts of my childhood, a lot of it in South America, most of it in different parts of South America, some of it, of course, in France, Africa, it's,
Yeah, you know how it works. Yeah, and how people can participate now.
Yeah. So to me, that's really, really exciting. And again, it's nice because it falls right out of the math, right? It's like, look, these equations are helpful. And my equation is just as helpful as the equation of, per equation, my equation is as helpful as somebody running some huge node, right? It's just proportional to whatever you did. And so that for us is really, really exciting. So the flex nodes we're starting with are just doing gossip. And then we're going to move to having DROM, so read-only memory, but again, much, much faster access than cold memory right now. And then at the end, we do DRAM, so read and write. So, a true random access memory. And then that's it. Then you have your computer, right? And that's basically what you have in your computer. You have your bus, you have your ROM, you have your RAM, and then everything else is the compute, right? And that's where pretty much a lot of the Web3 work has been going on.
Will it be possible to use Optimum from iPhone, for example?
So I don't see why not. I think that the biggest problems with iPhone are for just the operating system, right? It's not the easiest OS to program on.
But maybe Android, because I remember that Vitalik mentioned maybe 2 years ago, he mentioned that his dream is like having node operators that can operate from
Yeah,
their smartphones.
that's right. So certainly for just a Flex node, that's not a problem, as long as your operating system allows it. So, I don't see why you wouldn't do it. You can do it from a phone, especially because, most phones currently are connected most of the time to Wi-Fi. And so your connection is very cheap.
Yeah, because it's very relevant to African countries. People don't use laptops, but they use smartphones.
Yeah, yeah, yeah.
Every
So
person has.
exactly. So the amount of compute is very low. And definitely, as I said, in our test net, we have, we lower the CPU more and more. And definitely your phone is able to do more than, half a CPU's worth of work. And definitely has more than a few megabytes.
I know that you helped shape the Women in Information Theory Society. So, first of all, please share a bit about this initiative. And also, I have a question about what tech or Web3 industry can do more to help women grow their careers.
Mm. So, as I mentioned before, I'm an information theorist, comments of card-carrying information theorist. I was the president of the Information Theory Society. I was the editor-in-chief of the flagship Transactions on Information Theory. I was on the board of governors for over a dozen years. I was the program co-chair multiple times for the main conference. So I've been doing a lot of work with them. Things that was interesting was, even though, as I said, for me, professionally, it was great, professionally and personally. Where it's about 90% male in the community, and so we were trying to see what things could be useful to women, but we wanted to do it in a way where it was useful to everybody, right? You don't want to have something that not inclusive, that's not going to be useful to everybody. But you want, because very often, I think what happens is it's a bit like what they say, the canary in the coal mine. You may have issues that you go, well, some of the underrepresented demographics see them more, but it's usually issues that everybody has. So I'll give you an example. One of the issues was childcare, and of course, nowadays, you see all parents try to be very involved in their childcare. And so, what were some strategies, tips, or whatever that people might actually find useful? Very proud of the fact that, we would get, when I was running it, I was getting about 50% men attending. So basically, these were things that maybe proportionally women tended to be care more about, but clearly was affecting everybody, and in particular the younger. And so,
Yeah, because they're more open and they have more flexible minds, I guess.
yeah, and they wanted to say, well, look, really what you're talking about is, how do I maintain my career in a highly competitive technological environment while at the same time, um, you know, being able to go to the parent teacher conferences, or this event or that event for the kids, or how do I manage when the kid is sick, how, and how did you find, and they're basically just sharing, right? Because obviously people have to figure out their own recipe, but sharing tips, and also general support. And also it was great because there were more senior people, usually men, coming to find out, how could they be more supportive and effective as managers, maybe,
Mm-hmm.
in order to facilitate generations that were trying to be more in the kids' lives. That's just one example. As background, I mentioned, I had my first while I was still at university, but I have 4 kids. The level of entropy in the life was, very, very high. And so, part of it was, one of the conferences for that I was co-chairing, we did something where it's like, look, we're gonna have childcare resources. And it was basically like, look, you pay for it, but it's really hard. You're coming to a place you don't know. how do you line up childcare? And so we basically had a list of things that, older kids could do, summer camps, and then, so basically the local know-how, and we contracted for a reduced rate, bulk reduced rate with a childcare provider. So, things like that. So that really make a difference, and part of it is also I showed up with my kids, and then basically I see now people doing it, men and women, I think often maybe women started it, but then everybody benefited from that different approach. So that was the way I looked at it. So it was always, I think, to do something positive. I think it was something like the League of Women Voters in the US. It runs debates and so on. So it's clearly a helpful tool of democracy for everybody. It was maybe more started by women who needed originally maybe more that access and to find a way to get involved after getting the vote in civic life, but then benefits everybody. So I see that as very much in the same vein. And it's been going ever since, and I'm thrilled.
What advice would you give to researchers or people from science who want to go from theoretical work to practical and to build their own product business in Web3 or maybe beyond the Web3 industry?
That's a really great question. I'm looking for advice. I'm open for advice. I think one of the things I would say is going back to why engineering attracted me, right? That even as you're doing theory, even if it looks like some of your papers are just like, equations and propositions and lemmas and corollaries and whatever, you should always try whenever possible to program something or build something as you go along. And it's not just something like you're going to check the math. Obviously, you should be able to check the math by itself. It's actually to check that you have the right model and that you're solving the right problem. And so the engineering approach, which is the math goes hand in hand with the engineering, to me is crucial. Right. I think it's really important to, as you go along, to think of yourself as an engineer first and foremost, just an engineer who's very comfortable with the math. So you shouldn't be afraid of the math, because if you are, you're going to miss the big picture, but you also shouldn't be afraid or dismissive of the implementation. And then go where it takes you. If you say, look, I see that right now there is a need for this in the market, then take it. If there's not a need, and the need may come, when I was starting on decentralized coding, you could have told me that the need would have come in 5 years or 50 years. I would have believed either. But I knew it had to happen because, as we said, decentralization is a requirement, right? Eventually, everybody has to grow up and decentralize. But you could have told me, years, decades, either could have happened, but it will happen, right? It will happen. If you think that you've done something important, it will happen.
Muriel, thank you very much for sharing your expertise, for sharing your knowledge. It's extremely valuable to the audience and for me personally. It was a great episode. And guys, I will leave all the links to Muriel, to Optimum under this episode, so you can go check out and learn more about memory for world computer and everything related to this topic. Thank you again, and see you in the next episode. Bye.
Thank you so much, Daria. It was a pleasure.